Welcome to Module 3D, Specific Gravity and Absorption of Aggregates. Hello, my name is Tom Pertapillo. I'm with E&B Paving. I'm the HMA Design and QC Coordinator in the South. Entering my 43rd year in the material testing industry, and hope you enjoy today's presentation. Welcome to the continuation of the aggregate testing and aggregate consensus properties. You can follow along by looking in section 2.3 of your manual. All the slides of this presentation, as well as it will reflect what you will see in the videos later, will be presented there. Today I want to talk about 5 of the most vital consensus properties to asphalt pavement design. Not only understanding these are important from a design perspective, but understanding them from a QC perspective will add many tools to your tool belt for solving mixed production issues as a QC technician. We're going to be talking about 5 particular tests in this section, which can be split into 2 categories: coarse and fine aggregate specific gravities, as well as fine and coarse aggregate angularity and flat and elongated. In this first module, we discuss specific gravities of fine and coarse aggregates. In this case, we'll talk first about the fine aggregate. Understanding the weight, the volume, and absorption relationship in the aggregates we use in asphalt design is critical in determining the right amount of binder content or any other additives that we may add to the design itself. In the first video, we'll go through the procedures of the fine aggregate specific gravity.
Specific gravity and absorption of fine aggregate, T84. In preparation for T84, obtain approximately 1,000 grams of material passing the number 4 sieve according to R76. Dry it to a constant mass at a temperature of 110 plus or minus 5 degrees Celsius. Allow to cool to room temperature. Cover with water either by immersion or by the addition of 6% moisture, and allow to soak at room temperature for 15 to 19 hours. Decant the excess water with care to avoid loss of fines. Spread the sample on a flat, non-absorbent surface and expose the surface to a gently moving current of warm air. To check for SSD condition, move the material one side of the pan. Fill the cone up. And allow the tamper to fall 5 millimeters above the surface of the sand, adjusting the starting height to the new surface level after each drop, and distribute the drops over the surface. Remove loose sand from the base and lift the mold vertically. When the fine aggregate slumps slightly, it indicates that it has reached a surface dry condition. Some angular fine aggregates or material with a high proportion of fines may not slump in the cone test upon reaching SSD condition. For these materials, SSD condition should be considered as the point when one side of the fine aggregate slumps slightly upon removing the mold. If the material slumps past SSD condition, thoroughly mix a few milliliters of water with the fine aggregate and permit it to stand in a covered container for 30 minutes, then resume the process of drying and testing at frequent intervals until SSD condition is reached. Once the aggregate has reached SSD condition, weigh out 500 grams plus or minus 10 grams and inject the material into a partially filled calibrated pycnometer. Once the 500 grams has been placed into the pycnometer, fill the pycnometer up 90%. Manually roll, invert, and agitate the pycnometer to eliminate all air bubbles in the pycnometer. Once all air has been eliminated and before bringing the water level to its calibrated capacity, a paper towel or a few drops of isopropyl alcohol may be used to help disperse the foam that sometimes builds up during shaking. Once all air has been eliminated, bring the water level in the pycnometer to its calibrated capacity and record the total mass of the pycnometer, specimen, and water. Then dump the entire sample into a container whose weight has been recorded and suitable for drying. Rinse the pycnometer, being sure all material has been removed, and place the container in a 110 plus or minus 5 degree Celsius oven until constant mass. Once constant mass has been achieved, allow the sample to cool to room temperature and record the final weight. The weight of the container should be known so it can be subtracted out of the final calculation.
In this second module, we'll discuss specific gravity and absorption of coarse aggregates. The procedure will be somewhat different than it was you saw in the video for fine aggregates, but the answers we're looking for are basically the same. We want to understand the mass or the weight of the geological makeup of the aggregate, as well as the amount of absorption. Understanding these will be important in determining how much asphalt content that will be required in the mixes we produce. Now, the video.
Specific gravity and absorption of coarse aggregate, T85. In preparation for this test, the coarse aggregate should be reduced to testing size, sieved over a 4.75 millimeter sieve with all material below the 4.75 being rejected, and the material should be washed, dried to constant mass, and cooled to room temperature. Then the aggregate is covered with room temperature water and allowed to soak at room temperature for 15 to 19 hours. Once the 15 to 19 hours is up, drain the water, being careful not to lose any of the aggregate. Having a clean sink while doing this helps to ensure that if any aggregate is lost, you can replace it into the original sample. Place the aggregate in a large towel and begin to dry the aggregate to reach SSD condition. Saturated surface dry condition is reached when there is no visible standing water on any of the aggregate. Agitating the rocks within the towel by folding and rolling will get you to SSD condition. Once SSD condition is achieved, place it in a teared out container and record the weight. Once the weight is recorded, be sure that the scale is tore out with your basket underneath. Remove the basket and place the SSD conditioned aggregate within the basket. Return the basket to the water bath, shaking to release any air pockets that may have built up. Reattach the basket to the bottom of the scale and let it level out before getting your next weight. Once the scale has leveled out, record the weight of the aggregate underwater, then remove the basket from the water and pour the aggregate into a sample container for drying. Place the aggregate in a 110 plus or minus 5 degrees Celsius oven and dry to constant mass.
After watching the two videos of the fine aggregate specific gravity and the coarse aggregate specific gravity, we now come to the calculations to determine the specific gravity and absorption of the tests that we performed in the laboratory. The calculations are exactly the same for both of them, as the answers we're looking for are the same. The specific gravity of the aggregate, as we can see, A equals oven dry weight in air of the aggregate, B is the saturated surface dry weight in air, and C is the weight in water. A very simple calculation will lead us to several different gravities and absorption. The GSB, or the bulk specific gravity, is A, the oven dry weight, divided by B minus C, saturated surface dry minus C, weight in water, and divided by A. We also have other gravities that we'll use in the mixed design procedure, the SSD and the GSA, and the absorption. Absorption is also a very important number that we need to know to help us get an idea when we're designing mixes how much asphalt binder is required. In this case, we're determining absorption by water. Asphalt absorbs in the aggregate somewhat differently. Asphalt will absorb at the rate of about 65% of what water will absorb to. So from these calculations, we can get the GSB, or the bulk specific gravity, a critical number in the mix design, as well as the absorption, another critical number that we need to know. Specification and reporting. We report specific gravity to the nearest 1,000th of a percent. We report absorption to the nearest 1/10 of a percent. Absorption for use in HMA, less than 5%. Also, the ascending weight of gravities, the GSB, is always greater than the GSE, which is always greater than the GSA. Always has to be in that order. If any of these gravities are not in that order, something is incorrect in your calculations or in running the test.